I am starting some lessons on brain science. The book I am reading is this one. The Brain That Changes Itself, written by Norman Deutsch. And this gives a summary of what we can say frontiers of brain science. And I found this book very interesting, and because of which I am planning to review this. But as usual, my focus is not so much on the medical or physical side of it. Not so much on medical, but more on philosophical implications, and also to see whether the study of brain can help us understand more closely about consciousness, and the relationship with the mind and self, like this. So this series is basically on the brain. Okay. Since this is an introductory lesson, let us start with the basics. What do we call, first of all, brain? Suppose I ask, where is the brain of the scooter? And what function does the brain do? We can say brain is the one that controls the rest of the body. This one, brake, is part of the brain. Accelerator, is part of the brain. Gears is part of the brain. Take for example, what is the relationship between the brake and the wheel? Relationship it is that if brake is applied, the wheel will stop. What is the relation between accelerator and the wheel? If accelerator is applied, more rotation and more speed. So essentially, the brain is nothing but control system, coordination system. So this is the same role that human brain plays in relation to the rest of the body. But the only difference is that in a scooter there is a human rider. Scooter, so you are applying a brake or you are applying an accelerator and the wheels are being stopped or accelerated. But in human brain there is nobody outside. There is a self-regulated system. So you can take it is like what are newly coming cars. They are, self-driven cars are coming. In a self-driven car, there is no human being, but all the control systems will be there. So like that, human brain controls the rest of the body and coordinates. Okay. But how does this do this? There is one neurosurgeon by name Wilder Penfield. He is a neurosurgeon at a Montreal Neurological Institute. He conducted operations, surgeries on hundreds of patients, and he made certain observations on the way the brain was working. Penfield was the first person to understand that brain areas are specialized. Areas are specialized. For example, in the brain, different parts of the brain are related to different functions. So suppose in an accident a particular part is damaged, only this particular function will be affected, not the entire brain. So he found that there is a localization of senses and there is a localization of movements. So in this way, he came up with what are called brain maps. So like brake and accelerator are related to the wheels, there are maps in the brain. If that map is touched, he was using for touching purpose electricity. So this is subjected to electric sensation. If the brain part is given an electric stimulation, the corresponding body is affected. So this is how he mapped. And interestingly, he also found that certain memories also located at certain places. So if you give electric stimulus to the memory, people may have a lived experience of it, or a very clear, distinct memory, as if it is being lived. It is much more than simple recalling. So it appears that many things of the body are coordinated at the level of the brain, and plus also memories are stored in the brain. Now we have these maps. This current map. There is not much difference between Penfield's map and the more recent ones. This is a map of the brain. For example, Not that this side is sensory, this side is motor. It is that it is represented sensory this side. So tongue, teeth, gums, lips, upper lip, face, nose, eyes, nose, middle finger, rising finger, hand, wrist, leg, foot, toes, genitals. It's like this. Movement, swallowing, tongue, jaw, lips, face. So Penfield mapped both sensory localization as well as movement localization. It says our brain functions like well organized bookshelf with different spaces allotted to each sense or motor skill. These books must compete with each other for shelf space. As we increase skills in one area, the brain must take away the space from the nearest books. So this is how map of brain looks like. Okay. So for example, how did Penfield find? He would stimulate the hand part, and then see what is the movement to the hand, like this. And here he carried out certain interesting experiments. Okay. Patient was on the table and surgery was done on the scalp and brain is exposed, and Penfield is giving an electric stimulation. He noticed something like this. If the doctor asks, raise your hand, the patient raises his hand. This surgery is being done when the patient is conscious. Patient has to be conscious because he has to answer the questions by the doctor. Okay. So if the Penfield asks, raise your hand, then patient raises his hand. Then he sees the stimulation at a particular space in the brain. Okay, so Penfield asks, he raises, and there is a coordination between the brain area and then hand rising. But then Penfield, instead of asking the patient, raise your hand, he gives stimulation, and patient himself raises the hand. Then when Penfield asked, why did you raise hand? He said, you raised my hand. So when brain stimulated, patient said, you raised my hand. When Penfield asked to rise and he raised, then he said, I raised my hand. It is not fully clear what are all the philosophical implications of this, but what is clear, simple things are that there is a correlation between the brain map and the body. Body parts are mapped in the brain, which means arm is not simply the arm hanging onto the body. Arm has brain maps in the brain. So in that way, body is mapped on the brain, and through when the body is changing, brain is changing, or when the brain is changed, body will change. So there is a coordination between the two. At one time, people felt that these brain maps are fixed and they cannot be changed. But modern research says they are not fixed and they are in fact dynamic, and many changes are possible, and maps even move from one place to another place under certain circumstances. So we'll examine the dynamics of this in the next lesson. Thank you.